So we have our equation from the previous video, 50 over r minus 20 plus 210 over r equals 4. So this is a rational equation, and we know it's a rational equation because we see the variable in the denominator. So we identified our LCD in the previous video as r times r minus 20. So what we're going to do is we're going to multiply both sides of this equation by r times r minus 20, and that's the LCD. And the goal is to clear the denominators. So on the left side, I'm going to put the LCD over 1 because I will be distributing into fractions. So it's nice to kind of see it as over 1. Okay, so when I distribute the LCD to the first ratio, the r minus 20 factor will cancel out. So the numerator of 50 will be multiplied by r because that was the factor of the LCD that ratio was missing. Then I'm going to distribute again to the 210 over r, and now the common factor is r, so you can imagine the r's will be cleared out or divide out, but the numerator of 210 gets multiplied by the missing factor r minus 20. Now, on the right side, nothing cancels out. There are no common factors because there's no fraction. So 4r is going to get distributed into r minus 20. So now all we have to do is distribute, and then we're going to get a nice quadratic equation, and we're going to get to use our factoring skills. So we're going to get 50r plus 210r minus 4,200. And then on the other side of the equal sign, I distribute 4r, and I get 4r squared minus 80r. On the left-hand side, I will combine like terms. 50r plus 210r is going to be 260r. But then I'm going to jump right to the next step where I get the whole equation set equal to 0. So if you think this goes too quickly for you, you can pause and do your own work to get it set equal to 0 and then come back and just see that we have matching equations. So to get this equal to 0, I'm going to have 4r squared on the right-hand side. Then I'm going to subtract that 260r from both sides, leaving me with negative 340r. And then I will have to add 4,200 to both sides to give me plus 4,200. I should also notice there's a GCF of 4. So after I factor out the 4, I have r squared minus 85r plus 1,050. So now I need numbers that multiply to 1,050 and that add to negative 85. So my numbers are negative 15 and negative 70. So that means I get two possible solutions. Either r is 15 or r is 70. So now you might be wondering, well, okay, which one do I use? Well, now this is why it's so important that you look up on your paper where we defined our variables. Remember, we let r stand for something, the variable r. We let the variable r stand for the rate of the train, okay? So r is the rate of the train. So we have two possibilities. The rate of the train could be 15 miles an hour or 70 miles an hour. So again, you're like, well, 15 is kind of slow, but it's possible, maybe. But remember, the car was 20 miles per hour slower than the train. So whatever the train's rate is, I have to subtract 20 from that to get the rate of the car. So 15 miles per hour doesn't make sense because if I were to subtract 20, that would tell me the rate of the car was negative 5. And that's not possible. So we can exclude r equals 15 as our solution. And then we just want r to be 70. That means the train would be 70 miles an hour. And then when we subtract 20, the car would be 50 miles an hour. So we're going to get rid of the solution r equals 15, and we're going to use the solution r equals 70. So remember, plain old r was the rate of the train, which is 70. So the rate of the train is 70 miles per hour. So then when we take away 20 miles from that, 20 miles per hour, when we subtract 20 miles per hour, the rate of the car is 50. So there's our two answers. The train traveled at 70 miles an hour and the car traveled at 50 miles per hour.